Hi, good morning. This is Scott Dahman of PowerWorld Corporation, and I'd like to welcome everyone to the first session in our 2020 Western Region Users Group meeting. Our first presenter today will be Saurav Mohapatra, and he is with PowerWorld Corporation, and he is going to talk about just a summary of all the new features in Simulator version 22, which hasn't been released yet. I'm sure everybody's kind of curious about when that's going to be available. And we don't have a set date yet. We're looking at doing it sometime this calendar year. But we're also at the stage right now where we're interested in signing on a few of our customers to act as beta testers. So if you are interested in doing that, you can just reach out to me via email at scott@powerworld.com, and we'd be happy to talk with you about that if you're interested in evaluating Simulator 22. So, and then we'll have a second presentation after Saurav. It'll be Tracy Rolstad of PSC Consultants North America, and he's going to be talking about some aspects of generator interconnection studies. And we'll also try to allow some time at the end for just some general discussion if people have any questions. So with that, I'll turn it over to Saurav. And again, if you have general questions for the presenters as we're going through, the best way to do that is probably to submit them through chat, and then I'll try to moderate those questions when there's an appropriate break in the discussion. So with that, I'll turn it over to Saurav.
Thank you, Scott. My name is Saurav Mohapatra. The display that you see in front of you right now is actually a fictitious case that was designed by Tom Ogilvy's group in Texas A&M. So I'll be using it throughout this presentation together with a couple of other cases. But mostly I'll be working off some slides and trying to go back and forth between the slides and the cases to show you a couple of features. And if there are any questions, feel free to send them to Scott. I think Scott is moderating all the questions. If I will try to stop maybe 2 or 3 times in between the presentations to just see if there are any really pressing questions, try to address them there. If not, let's collect all the questions and hold them towards the end, if that's possible. So my extension is 23, and my email address is as it is written on the screen. So feel free to reach out to me or anybody else at PowerWorld with any questions you may have. If you have any doubts about older features or newer features that have been added recently, definitely feel free to reach out to us about any queries you have. We have not released version 22 yet, as Scott was saying, but we do have a list of several enhancements and a couple of new features. And this slide set kind of is an attempt to make a summary of all the different features. There might be other features that have not been documented yet, and we will get to documenting that soon. So today I'm just going to go pretty much alphabetically in terms of what categories these features belong to, and you'll get a sense of that once I start going through the slides. So Simulator 22 is again going to be only 64. You may already know 20 and 21 have already been a 64-bit version, and Simulator 20 was the last 32-bit version that was available. So we only have the 64-bit simulator installed, and you will have the program file installed in the simulator package installed in the program files directory in Windows, not the program files 86 directory. So the first kind of group of slides here kind of go through several auxiliary script related scripts and commands. I'm not going to go through each and every one of them. These are just a sampling of few commands that we have added recently. For example, this first one over here This is something that is called not a script command, but it's something which can be used within a script command, let's say a special keyword. And these two keywords were added recently. So for example, you could, let me switch over to simulator and show you a quick example. So let's say you have a file like this, which is open. There's a section called tools where you can open up the script execution window. And I'm simply going to copy paste the script that I showed you earlier. So usually when I'm executing scripts, I will try to keep the log window open. So in this case, it is actually going to, it's going to show me whether the script actually worked. And it's also going to show me whether it's actually, and we're also going to save the log, so we will be able to see the exact log that's saved. So I'm just going to enable timestamps to make sure this actually works right now. So with this script command, I can just go ahead and hit enter. And it seems like it worked. And let me see if I can find the text file which was created as a result of this script command. So it looks like this was the file that was created. And you can see if I scroll down to the very bottom of the log, you will see this particular script that we just executed, which is included in the log, and the script itself that was executed is also included here. And as you can see, that contains the @casename command, which can be used in any script command as a special character, a special keyword. So that's just an example of one script command. And the reason why I'm showing you this script execution dialog is because many of our script commands are usually put inside an aux file. But what I usually like to do is test it out here first and then put them in an aux file so I know exactly what I'm getting. Just trying to get back my presentation. Okay, so that's just one example of a script command, and you just saw how to use it in the simulator window. And of course, the eventual goal would be to put it inside an aux file or even use it as a script command in your SimAuto code. So there are several different script commands such as ATC related, case related, contingency related, and so on that have been added. You will actually find all these different script commands listed on our aux file PDF documentation. I will just show you that in a second. And that is actually the place where we keep all the different aux files on the website. There's two different places. One is the knowledge base, and the second is the web help. And you should be able to access the latest version from here. I encourage everyone to take a look at this file because many of this has been compiled over the years and has a lot of useful information about each and every script command. For example, I have this file pulled up right now. You can see this is an exhaustive list of all the script commands that exist in simulator currently. And if I just do a search, a control F on this file, I'll be able to go to a line-specific script command and take a look at it. For example, this ATC write to Excel, it has been modified recently. It's not a new script command, but one of the field list arguments has been added recently. And you can see in the documentation exactly when it was added, what that extra argument does. And as things have been added just recently. So we try to keep this document updated as often as possible. So now kind of changing gears, many of these slides are just snippets of what's going on, so it might feel a little bit disjoint. I've tried to group them in whatever best way I could to try to make it continuous. But for example, this ATC slide is going to be quick, quick 2 slides. This is something that we are currently working on. So in the current ATC tool that is there in PowerWorld, it only allows you to run one ATC transfer at a time. So define one source sync and run the transfer. But what we are trying to come up with is a way to run multiple directions at a time. And that's something that's in the works. And it is definitely expected to be complete when we release version 22. For those people who use HEC on a regular basis, there is a new option that's been added. In ATC settings itself, there is a way to save ATC options and results. For that particular dialog, there's an option now to use the concise format. And while using the concise format, by default, it's not going to use any of the subdata sections. So this feature has been added into 21 as well as 22. In 21, it will be left unchecked as the default, but in 22, it's going to be checked. So going forward, it might just be more easier to use the concise format because it's easy to read. So that's something just to keep in mind as you continue using ATC. Again, switching gears again, this is about bus view and substation view on one lines. It might be easier to actually show you this on the screen. So if I have a case open, let's pick up a small case just to make it easy to use. So if I have a case open, I can always right-click on one of these and go to bus view. So for example, this is a bus view, and if you go to define custom view, that allows you to actually define a custom view for what you're looking at. So I just gone ahead and created a custom view where I'm only interested in looking at bus and branch state values, the voltage, angle, flow, and so on. And I have saved that as one of my custom views. So what this custom view feature does actually is, let's say I open another case which has referred to the same custom view, or I reopen the same case. So when I do that, this item will automatically be refreshed because it's being now stored in the registry settings instead of the case. So if I go to...
Hold on. Are you girls done?
In another case, what happens is I'll be able to get that bus view directly in the case. That's just one convenient feature that's been added recently. The other thing is in case information displays, what I'm showing you right now is the different fields that are available in case information displays, particular to branches. And due to some requests from our customers, we added this special category of fields, which is basically a calculation of percentage used based on a contingency rating limits, and that can be viewed from the grid itself, from the case information display of the branches itself. Now, this is something minor, but I useful and looks very neat. And this was added just last week, actually. So this is about quick fills. For those who don't know what quick fill is, it is this little square button or square feature that you see on the lower right of these cells and the lower left of these cells. So this is just being changed where, depending on the text quantity or a numerical quantity that's in the cell, the quick fill button is kind of going to realign itself. And I will show you that later on when I'm working in the case information, one of the cases. Again, in the case information displays, I think many of you are familiar with how you can simply right-click on one of the grids and set toggle columns and show column metrics. But now we have also added the capability of seeing the row metrics, and this is there in all the grids in Simulator. In some grids, it might make sense to do it. In some grids, it may not make sense to do it. It is particularly useful, and it was especially for the transient stability results field, because each column refers to a signal and each row refers to a specific time point. So you have the capability now to kind of have a slice across time or across one particular. So that's something that's handy to have. And again, we will look at this once we work on some of the cases. This is the last slide for case information displays. As you know, there's a right-click option on the grids to save out as auxiliary file. So now this is an option to actually save data out as auxiliary file with options, and the options will allow you to use one of the auxiliary export format descriptions. And this is one more of those features that we are currently working on and will be ready by the time we release version 22. Now, moving on to a different thing, contingency analysis. This is, again, one of the tools that is available. So for these sets of slides, it might be easier for me to switch over to the software and just show you what we have actually added instead of going through the slides. We will publish the slides later on, and you can go through the specifics in the slides later on. So I'm going to switch over to the software right now. So this is another one of those cases that is depicting ERCOT. Again, this is not a real case. It's a synthetic grid. So I'm going to try showing you a couple of different things. The first thing is to do with model planes. For those of you who are not familiar with model planes, it's used as part of remedial action schemes. And what a model plane basically is, it'll actually become quite evident once you look at it. It is built on top of model. So let's look at what model expressions are first. So one model expression refers to a criteria that is placed on one of the quantities or fields of specific object in simulator. So this, for example, is a bus object, and I have picked out a particular field called the through flow. So here you can take a look at the field that is selected, and that itself is the output of that expression. You can make a more advanced function, but I'm just keeping it simple for this presentation. And so that's how you define a model expression. You could make it a function or of one or more, two or more different fields. You also have the ability to look at the different by primary, secondary, and label. So if I switch this, you have the ability to see this as part of see this definition in terms of the secondary label or the primary label, or the label itself, which is probably not defined in this case, so it's defaulting to the previous view. So with a model expression, now you have the capability to define model planes. And the new thing that's been added is a tool which allows you to define the model expression, model plane visually. So not many people might be using this at this point in time, but I think I wanted to talk about this tool because it's really easy to see whether you are currently meeting the criteria of that field or inside or out, or exactly how you're defining this. So for example, in this case, I have defined a model expression, which is the green area here. And currently, it is in the red area, which means it is not meeting the criteria. So when you have a contingency action, the black dot that you see here, which defines the state, might move inside the green location, and that's how you know criteria has been met. So this is very useful while defining model planes and also just observing different results in some cases. People who are using remedial action schemes might find a good use for this. So this has to do with contingency analysis. So let me move to the contingency analysis window and go through a few new things that have been added, more like feature updates or enhancements rather. So previously, when you were to insert a specific contingency, you would try to add a new contingency element right here. And once you insert a new contingency element, previously what would happen is you would have to do one by one. So the window that just opened up you would have to hit OK, it would close, and you would add a new contingency by clicking this button again. Now, what's different, it's a very simple change, but I think it will make life a lot easier. You have the ability to insert, save, and delete. So for example, in this specific contingency definition, there's only one element defined. I can add several different elements. So for example, if I just say I want to add a load tripping, so I can just choose a specific load, make sure the load is selected here in the element type, choose a specific load, and hit open on the action type and do insert. And let's say I want to add a bus opening up at the same time, so I can pick a bus, make sure the bus is selected here, pick a bus, and again hit open and do insert. And I can take a look at what all has been added. And let's say I realize that one of them is incorrect, then I can hit delete, and it will prompt again. I can hit yes, hit OK. So what I did was basically added multiple contingency in one go instead of having to do it one by one, where that window keeps opening and closing. So this again is a feature that's been added because some of our users requested for it. So if you have any features that you would like to have function differently, please reach out to us, and we will try our best to add it to even the same version of the software in some instances, or the next version. So there is one tiny thing that we also added here, not this window. So if you right-click on this grid, you have insert. This allows you to insert a completely new contingency from scratch. In insert new element, there is now, which is also defined. Oh, I'm looking at the wrong folder. What I meant to actually show you was in the auto insert tab. So what I just showed you was to insert a single contingency, but the feature that I wanted to actually show you is in the auto insert feature here. In the auto insert feature, just loading up. Auto insert feature, we have ability to put in a single contingency or a combination of contingencies. this single load contingency that you see here has been reset again because one of our users wanted it. The other thing that we have recently added, if you right-click on one of these contingencies, you have the ability to actually save as, and it gives you a PTI file format. We didn't have this feature available earlier, and this was just added recently. Now I'm going to switch over to these slides. There's a couple of things that are new and also another script command related feature that has been added. This is to do with remedial actions. I'm not going to go through the specifics of what remedial actions are, but there is a new feature that's been added to delete remedial actions and any reference dependencies, be it model conditions, model filters, model expressions, and so on. And it's very tricky to have these remedial actions defined in the way you want it to, especially when you're working across a large number of aux files, a lot of different cases, and it's quite easy to get them wrong. So this feature is basically a way to start from scratch, and it's an easy way to remove the dependency, so you know that nothing being referenced in the software is currently not available as a defined model condition, filter, or model expression. This is a feature that is in the software as well as, so you can use it in either way. This is the slide on the PTI contingency data in the right-click Save As section, which we talked about. Now, this is probably the most significant addition or change that's going to happen in the contingency analysis tool. Currently, the contingency analysis tool allows you to run through one list of contingencies. And there is actually a way to do n-1 or n-2, whichever terminology you might be more familiar with. But this new tool is going to give you a way to manage all the contingency lists in a more, basically in a more manageable fashion. Because it's not going to enumerate through all the contingencies that you might be running as part of each n-1 contingency. But instead, it's going to maintain two lists where it's going to pick one contingency from the primary list and then pick another from the secondary list and mix and match. So in that way, it is easier to keep track of the whole set of contingencies that you're running without having to enumerate all of them and have them defined in your case. So this is the current capability that is there, and it's a feature called Join Active Contingencies option. Basically, this allows you to join two contingency lists to run after one another. So each contingency list, let's say you have, a 10 contingencies defined. The first option here will allow you to join with itself. So what that means is basically n choose 2 of each of those 10,000 contingencies. And as you can see, that's a really big number. It's close to 50 million. And there is no point in actually having all these defined in the case. This is the current capability that is already available in the in Simulator 21. But we are going to make it a little better where you need to define or explicitly define all these 50 million combinations, and hopefully that will be easy to maintain over the long run. So this other thing is to do with difference case. If you are running contingency analysis or comparing cases, you probably already have used the difference case tool. This feature is a slight modification that's been done recently. So when you have a grid, now you have the capability to see rows of different objects that have only changed fields that are being displayed. So a quick example of that is what you see on the left, on the right side here. So the top right shows you a list of buses where only the per unit volt has been changed on one of the buses. But imagine looking at a bigger case and you want to see only the buses that have changed. Now that feature exists, and you'll be able to select this in the drop-down menu to show only changed, and it will only show the rows that are changed. And currently, this is only available in the user-defined grids. I can quickly switch over to simulator and show you where that is. So, for example, this is a user-defined grid. So that's at the very bottom here, called under user-defined. So what you can do here is right-click on that folder, and you can insert defined grids of any object that you like. In this case, I had bus, and that's what's being displayed in the back. But you have the ability to pick any object type you want. That's a object in simulator. So again, coming back to this, let me see if I can quickly show you. So the way you use difference case is you look at difference case option inside tools tab, and you can base. And just to give a simple example, I'm just going to change this per unit voltage to 1.0. Instead of 0.98. So I had already set the previous instance as my base case. So now my present case has already changed because of the change I just made to this voltage. So what I can do is do difference case and do change mode. And that shows you only one row that has changed. But this option right here, it's show only changed. Looks like there might be a bug here that needs to get worked out. I'm going to take note of that. But basically, the option should allow you to only see the rows that have changed instead of looking at all the rows. I think I might be. Let me see if I can get this right. Okay. Okay, looks like this is a bug, so I'm going to take note of that. All right, so moving on to the next thing here. So the next thing here is about distributed computation. This tool has been around since the previous version or even the version before that. But now it has the ability to actually select specific user groups. So for those who don't know what distributed computation is, it allows you to run things like transient stability or contingency analysis, just state contingency analysis, by finding all your different contingencies to several different processors that can be located on your machine. Nowadays, each machine comes with either 4 or more cores. So you can farm it out to different cores on your machine or farm it out to different computers. So this is a very easy way to actually get a lot of time-saving benefits. And the distributed computation tool has been made really easy to use, and it is available both as a GUI, a user interface, as well as tool. So you can also have your IT administrators set it up for you using the script. So before I go into file format, so I think I want to show you a quick example on what or how to use this distributed computation configuration. I'll also show you a quick example on how it runs. So it is literally as simple as it sounds. So I'm just going to go to the start menu here and click and type distributed. Looks like it already showed up here. So distributed computation configuration for version 22. That's the one that I need right now. So I'm going to select that, and so it's going to show up. So I have already set up, but if you want to select a particular user, go ahead and select it here and hit apply, and that should take care of it. But for now, I don't need to because I already set it up once. So what this allows you to do is look at one of the cases. Let me pick a case which is easy to show what's going on. Okay, so this case right here is the 2,000 bus case. So if I go to tools, analysis, looks like I'm still viewing. Let me clear this. Okay. So in contingency analysis, I want to show you how to use distributed computing, which is really simple to use. In here, in options, there's a tab called distributed computing. So I have already set this up, but what you can do is you can choose your own local host as, which means your own computer, and go through these options here and choose either your computer or different computers on the same network you have access to. And once up, you can simply use the same interface and do start run. I just want to make sure I have selected only a certain set of contingencies here. So I have selected about 500 contingencies out of a list of 4,000. Just for the sake of this demonstration, I just don't want to keep running contingencies while I do the presentation. So I'm going to hit start run, and it's going to prompt you basically, do I want to clear all the values that are present there or not? So I'm just going to choose yes. Now, as you can see in the lower left here, it's just going to start up the sim auto processes, which handle the distributed computation process. So looks like it's going right now, and it should be done in about 1 or 1.5 minutes. So looks like it's going. It's already 150 contingencies out of 500. So it's pretty fast, and I might have it run faster if I had selected 100 contingencies per run. So what it's doing behind the scenes is basically farming out contingencies to the different processors that I have on my own laptop. And and it's getting back results and collating it for you to view in the same GUI that you are always using when running it without the distributed computing. Looks like it finished, and now it's finished with 241 violations. And I can go ahead and click around and look at the results. So it's a very simple to use tool, and makes running things a lot quicker. So for those customers who might be interested in using this, feel free to reach out to us, and we'll be happy to help you out there. Now, the next set of things is, I'm going to stick to the slides just to go over them quickly. This is to do with formats. Every time when we release Simulator, there's a couple of new file formats that have been improved, or we have now added the ability to read and write different file formats that were not there before. So same for this release of 22. There's a couple of additions or improvements rather to the OTG, PSLF file formats. In PTI, we have improvements to the MON file formats, IDEF files. Also in GIC, geomagnetically induced currents. Now the GeoJSON file, which has E-field input as time series, that's also readable now. There's going to be a presentation next week. Scott Dahman is going to present that. That presentation will go into more details of what this specifically does, along with several other GIC-related features or enhancements that have been done. Also, this is a new file format that the simulator can read right now. This has been added to version 22. This is the GMD format. We have the ability to read a couple of different sections, and the constant E-field and E-field sections are something that are being ignored right now, but we will probably look at recognizing them in the near future once people start using them in PSLF. This is to do with both, I guess, one-lines, contouring, as well as gigs, but this specifically is more closely related to gig. We have added the ability to see spatial data. If I have time later, I can show you as part of a quick demo. What this is basically a way to visualize things like E-fields, which are not necessarily associated with one specific power system object, but it is basically a spatial data. So you can now contour it on a one line. And right now, these are the only fields that are supported. In the future, the other fields too. So this is just an example of that E-field that's being contoured, which is a spatial data. This is something which is really minor, but again, I think this is again added because of one of our customers asking us to. Search bar, which allows you to look through the search description, the case description in a particular file. It's not enabled by default, but it's quick. It's pretty easy to enable it. Simply right-click on the toolbar, and you get it to appear either at the top or the bottom, and you can do a quick search. This is something that I think I already showed you. When we were looking at that model expressions dialog, now we have the ability to actually use different identifiers, either the primary keys or the secondary keys or the labels. And obviously, this doesn't affect the model expression dialog that you're currently viewing. It doesn't affect anything else, like a string grid or a case information display, rather. We already went through this previously. This is to do generally with pretty much any user interface dialog. If you right-click on the dialog caption bar at the very top, you have the ability to export or copy to clipboard. Export means you'll be able to save it as a JPEG or a PNG, any image file format, into a directory of your choice. Or if you want to copy it to clipboard, it's exactly the screenshot. So hopefully these will just help add convenience while you use Simulator. This is something that I can show you again on the GUI. We already had custom fields. Many of you might already use custom fields. And what this feature gives you the ability to do is specify a list of values that you want to include in your custom fields. So this is similar to something like the validation feature in Excel, where you specify it to validate to a specific list. So that is the same ability here, and it allows you to specify lists which can be integers, can be floating points, or it can be strings. So again, a way to capture information that is not already available in the simulator. So you can keep track of your fields more efficiently in this way, hopefully. This is, again, something very general. In PVQV, we have the ability to now include load, megawatt, and megavar quantities to be tracked and plotted. This was previously somehow we had not thought of adding this earlier, but now they are available. Moving on to calculated fields here. Calculated fields has a new option called extra identification. This is very similar to the so-called VLOOKUP feature in Excel, which allows you to look for a value in a specific column and then find the corresponding value in the same row of value that is found in a specific column. So one example of this would be to look at, let's say you are trying to find the bus which has the maximum voltage in a specific area or all specific areas. What you can do is you can use calculated fields, and now instead of just getting back the max voltage per area, you'll also get back the bus name which the max voltage corresponds to. So this is a really handy feature that can be useful when you're trying to aggregate data and trying to see, trying to sieve through and find the relevant information from you, especially looking at areas, zones, and so on. So for contouring, this is to do with one programs now. We have added a new feature in the contouring method, which is called the delineate triangulation. It's faster, and it is really useful while simulating cases where you have a one-line contour that is being continuously updated. And currently, the speed up is significant, but we are working towards making it faster. So in terms of the one-line display, this is the current one-line diagram that is using, sorry, the current contouring method that is using standard the Shepherd's method, which is based on, you can think of it as like circular patches, overlapping circular patches. But the triangulation method is going to look slightly different, but it's pretty much going to be information. The primary advantage being it is going to be faster to compute. So hopefully you'll be able to see continuously changing contours and see it smoother on your screen. Or if you're saving it out as a series of JPEGs, you'll be able to do it much faster. This is something that's been added to the contour option. You have the ability now to right-click on the contour itself and look at the contour option based on which specific color you might want to look at, which defines how intense that particular field is. You might want to drill down to the specific object that corresponds to that that object on the one line. So now you have the ability to do it. You could also right-click directly on the one line and go to the object dialog that way. So just an alternative way to do the same thing. This is another neat feature that was added probably in the last 3 or 4 months. In one-line diagrams now, we have the ability to read in shape files more effectively. Shape files, they're not written in lat-long coordinates, so we have the ability to now convert the values to lat-long, which simulator can now use to display it properly on the PowerWorld coordinates, which are then used to display it on the one line. So that's just a quick way to shape files useful. And people here inside PowerWorld have used it and found it quite useful. So if you use one lines often, this is a feature that might be helpful, and you might use a lot of information that might already be available to you. Okay, so now we're going to switch gears here. So I have been looking at the WebEx thing, and it looks like there are a couple of questions going back and forth. So I think I'm going to keep going.
Saurav, there are a couple questions with Model Explorer and things like that maybe it might make sense to address before we get into different topics. Okay,
yeah,
so
I have an easy way to look at the WebEx chat window. So so go ahead, Scott.
Okay, I was going to say I can ask a few of them just so everybody can hear, and that way that people don't need to look at the chat window, I guess, to see them. There was one that was addressed earlier that I think I addressed, but maybe there's some more elaboration that can be done on it. There was a question from Bryant Hicks at Salt River that asks if there are plans to add GPU hardware acceleration. I think just in general to PowerWorld. Now, of course, we've been doing that with contouring for many years now, but it doesn't. That functionality does not go outside of contouring, and I think for the moment that's not on our drawing board. But if you have anything to elaborate on that, might be useful.
To the best of my knowledge, contouring is the only thing in PowerWorld that has the ability to leverage GPU power right now.
Okay.
I think that option is available somewhere here. Yeah, it's use GPU to accelerate contouring. I'm not sure if you're able to see that on the screen right now. In terms of using GPU more generally, we have had some conversations about that, but we don't have any particular, concrete plans as of yet. But that is definitely a field we are generally looking into. The idea being to make computations in parallel. So far, the bulk of our development efforts here at PowerWorld has been in distributed computing. So that's the tool that I showed. So the idea being that you run a lot of different contingencies in parallel and leverage all the processes that you have available to you, rather than running one contingency in parallel by itself, which might give you similar speed ups. Also, just an alternate approach. But if there are certain situations where you might think having things running in parallel in just one single run might be useful, that's something we can definitely have a conversation about and see how to include it. For things like contingency or transient contingencies, people are running, thousands or tens of thousands contingencies at the minimum, so it makes perfect sense for computing. But if you think of something else where that distributed computing idea doesn't completely make sense, that's somewhere we can probably look into to maybe start having a conversation. Hopefully that answers the question.
Okay, another question related to Model Explorer use specifically. Is there any thought on adding a double-click autofill down functionality? And I'm not exactly sure what that is in Excel. I guess, Daniel, if you want to unmute yourself and kind of elaborate on that, or Saurav.
Yeah, I think I understand Daniel's question.
Understand that? Okay.
Yeah, so in Excel, when you have, when you have, let's say, columns filled and you have already filled a formula in the top left cell, you can simply double click on that and it will try to autofill down to all the rows that are defined in your specific table. Currently, we do not have a way to actually do that. The only way that exists right now, or I guess two ways that exist right now. So let me open up a Model Explorer grid that would be helpful. For example, right now I'm looking at the generators table here, and currently one way is to look at the fill option and hold it down and drag it. So right now, let's say I want to change this to open. So what I can do is double click, change it to open, and let's say I want to open a couple of different generators. I can just do it this way. So that's one option. The other option is to right click and do set toggle columns and toggle all to a specific value or set all to a specific value. So those are the only two options available. And obviously, you cannot use them on the grid without it being filtered, I think, in most cases. So if you're using it with filters, you can filter a specific list of generators that you want to work on and then apply it based on that. So let's say you want to apply it on a specific list of generators. I don't know if I have any filters defined in this case currently. But I think you get the idea, where you choose a specific filter, and instead of all the generators in your case, you look at a subset, and that way you can choose, you can quickly choose, I guess I don't have a filter defined, but let's say I choose a filter. It seems like when I'm using my screen sharing on WebEx, it slows everything down in terms of the GUI in PowerWorld as well as other software. So that's why it's loading a little slower than usual, which is probably helpful because I don't want to move too fast for people to lose track of where I am. So here, let's say you want to look at only generators in a specific area or something, or let me do it a slightly different way.
Saurav, we are getting kind of short on time, so it might be good to.
Okay, yeah. I guess
back.
I'll skip that example for now, but I think I elaborated it sufficiently where you can do it in two different ways right now, but not the double click way.
Okay.
Yeah, and there's Saurav, can you hear me?
Yeah, it is faint, but I think
Okay.
I can hear you.
Yeah, Jamie. The other worry I would have is if we added a double click feature, somebody might be double clicking to change close to open and accidentally click on the little X and then open every generator.
Yeah, that's
I'll
true.
talk to Daniel offline. I'm a little worried about mass accidental changes with that. So.
Yeah.
Okay.
There is one more question related to transient, and maybe it's something that you can address as you're going through your last few set of slides, Saurav, or maybe Jamie, you might have some ideas on this. But the question is, will simulators start supporting post-transient and transient stability cascading analysis?
I don't really know what that means specifically, but probably the answer is yes. But we just have to figure out how to define it exactly. But I mean, this is probably one of those conversations that we'll probably have offline to see exactly what, if it is modeling a set of different contingencies, one after another, or maybe it's to do with remedial action schemes being supported in transient stability. That would be possible, but let's talk offline about that question.
Yeah, we can defer to the end of all the discussion too after Tracy's had a chance to speak. So.
Yeah, that sounds good.
Okay.
So the last set of slides here is pretty much all about transient stability, and I'm going to the slides and then switch over to the case if we're still good on time. As usual, we have added a couple of different models I'm not going to go through each of these models, but usually we try to group them into the existing folders that are there in simulator. Oops, I think I skipped to. Yeah. So these Exciter models here have been actually around since version 21, but I want to our users that these are as per the IEEE standard of 2016, and we have these around. So if people want to use them, please do use them. The two main things that I wanted to cover upon is the auxiliary controller model. So now what is an auxiliary controller model? It's basically an additional signal that is fed into around the same point where a PREF control signal is fed into. So for example, this is part of the REECD block diagram, and you have PREF coming in on the left here. And this would be something that kind of combines with the PREF signal to provide a momentary boost. And the idea here is to model inertial-based fast frequency response, which for certain wind turbines, which have a certain amount of inertia in them. So in the short time frame, you leverage that inertia, and then in the longer time frame, you kind of return that inertia, that energy lost from the inertia back to the rotating wind, the blades or the turbine. So that's a separate set of controller models that's been added. They're called aux controllers because the signal they're outputting is an auxiliary P signal or a real power-based signal. Now, there are a couple of other plant controllers that's been added. Again, this is with the IEEE standard that we talked about. These are plant controllers, but they only have a VREF or a reactive power control signal. So whichever model actually takes an input VREF signal, you should interface it with that. It may not make sense to use it with all models, but for now, we don't have we have not enforced that this model go with specific models, but it's definitely not to be used with all different kinds of models, only certain kinds of models where it makes sense to have this VREF controller. This is to do with transient stability as well as remedial action schemes. We didn't have a way earlier to switch to set to or change by. Now these are values, so these are features available in the transient contingency element dialog and the remedial action element, where you can switch values using these options as a percent of the start nominal value. It's a small feature that's been added. So remedial action support in simulator has been growing, and this is to do with transient stability. That's also been added to transient stability. Now, not all fields are supported in transient stability. So if you want to see a list of fields that are supported in transient stability, you can use this button in the remedial actions tab and exactly the fields that are currently supported. And if you've come across a field that is not supported, please reach out to us and we will look into adding it. And for now, we have just been growing these fields and adding more and more support for RAS in transient stability. Transient stability, again, now has an additional feature of branch limit monitors. This is to do or add on to the synchronous generator limit monitors that was there in previous versions. So what it allows you to do is to track quantities on a branch, just like you would track quantities on synchronous generators. It does make sense to use this when you don't have relays defined and so on. But in some cases, it does make sense to use it without, even with relays defined. For example, other softwares have a feature called out-of-step monitor, which basically large power swings between two geographically distant areas. So that's a neat feature to have and can help you in doing transient stability simulations. This is another feature that's been enhanced, redesigned rather. It's about inserting distance relays. Right now, this feature is available. Before you run any transient stability simulation, you can go in there and auto-insert relays. It's particularly useful if your case does not have relays, and you can quickly put in some default values and insert relays at a subset or even all branches case. It may not make sense to insert it in all branches, but definitely a subset of the branches that you're interested in. The other thing here is, again, just informational things, but it's particularly helpful to get a sense of how much load has tripped during a simulation. And now we have added two called relay tripped and model tripped. So what that means is if a load tripped because the actual model tripped, like a motor model tripping, it would count under model tripped. And if a specific relay that was up a condition and tripped a set of loads, that will be counted as a relay trip. So it's really helpful to know what tripped or how it tripped. It can help in sometimes figuring out what happened, and if something unexpected happened because settings were not set right, you can drill down deeper. But just to get a start or a starting point of where to look, this is really helpful. I think right now for these last like four or five, switch over to simulator. So in add-ons, I need to, okay, so let me see which case I'm currently using. So I have this wet, or rather fictitious wet case that I already ran transient stability earlier on. I think I have ran it for maybe 8 different contingencies, and I have results already saved. So in here, once you have run your transient stability run, you're looking at plots. We already had the ability to define plots, and when you have plots defined, you had the ability to save them during the run. Options here. So the two different things that are new this time are to do with saving the plots after actually the simulation has been over. So you have data collected already, and if you want to go over and make new plots, you can definitely do that. You can define your plot and do save plot images for autosave options. So right now I have already ran all the simulations. So I can easily just, these are like maybe 7 or 8 different plots. So if I hit save plot images for autosave options, it's just going to go through these and save all these files for the specific contingency that I selected. So right now I'm in the one contingency at a time view. You can switch over to the multiple contingency view and it'll be exactly the same, just that it will go through all the contingencies that you have saved results for. So to give you an idea of what it looks like, I just hit that save button and that created a PDF file with plots inside of it. These plots are fairly basic here, but you can always format these plots with additional information and have a set of plots within one PDF file, which might be really handy to have rather than a couple of JPEG or image files floating around in the directory. So that's something that's been added to save it after the simulation has been done. And the second feature I just showed you is actually save it to a PDF file. The PDF file actually did not exist as one of the options. It was just added in the last 1 or 2 months. So in addition to doing it as individual files, which might clutter up a directory, you can save it as a PDF file, which will combine all the plots that are set to save as a PDF into one file per contingency. So that's another neat way for you to manage all your output data. So one more handy feature that's been improved is people might already be familiar with transient limit monitors. So in transient limit monitors, we have a couple of monitors that are predefined, these ones here. But for this case, I'm just putting in something very simple, which is V per unit less than 0.95. And what this button gives you the ability to do is to reevaluate it even after the simulation has taken place. So if you have saved results in a TSR file or in RAM, you can click this and it goes through them pretty quickly and picks out all the different violations that occur and stores them as monitor violations. So you don't have to define your monitors in advance now. You can save the results and then run or rerun the limit monitors if you choose to. So that's something really handy that has been added recently. Looks like it's still running. Okay, I'm just going to switch to another simulator window and let this keep running. Now, the last thing I wanted to show you is to do with transient stability. There's a new feature called Transient Stability Result Analyzer, which Jamie is going to talk about in next week's session. For now, I'm just going to show you where it is in simulator. One is called the Transient Stability Analyzer, and the second thing, which has already existed for quite some time, has been enhanced. I'll show you that, which is called frequency analysis. So in transient stability, if you look at a case which you already have results for, oops, looks like I just closed the case. Give me one moment. Okay, so it looks like I have the case open here. So in Result Analyzer, which is the new feature that I was talking about, what it allows you to do is to define a specific time window within your simulation. So you can insert a specific time window and specify a start time and end time. You can select a certain set of signals and so on. So I'm the time window that I already defined earlier. And if I calculate the statistics and signals and modes and so on, I should be able to see some statistics on the different signals that I had saved earlier in the case. So it looks like the calculation is over. So what this gives you is basically a way to quickly go through your results and see if anything is out of the ordinary. If you want to look at modes in your case, so it looks like this case is three dominant modes that's going on. You can click through the different signals, and there's a reconstruction window here that I have set to auto update. So you can click through these signals here, and you can see that it's reconstructing the signals based on these modes that were calculated. So this is a very recent addition, and Jamie is going to talk more about this. So I'll leave that to Jamie to talk about next week. The other thing is, if people like to look at time values, the actual time series values from RAM, you can go to the results from RAM time value section. So I think in this case, I had saved the substation values, or maybe it was the bus values. Okay, so I think I saved the bus values in this case. So I'm just going to look at bus frequencies, for example. And with this, what I can do is right-click and do frequency analysis, which is in the local right-click menu. So what frequency analysis allows you to do is, so I'm going to choose all and include all times. So what it allows you to do is look at basically a summary of signals and do FFT and a few other things that have been added within the last 2 years. This signal summary section is something new. So if I do update frequency analysis, I'm just going to remove the FFT because that's a little time consuming. So now over here, you see a list of that I was looking at earlier, and it gives you a quick way to kind of see what is going on, the range of the signal and so on. Where this is particularly helpful is to check whether your simulation has actually gone to state. So instead of including all time, I'm just going to include the last one or even just 0.5 seconds, or let's say 1 second of the simulation, which is 9 to 10 seconds, and update the frequency analysis. And if you look at the range here, you can rank it from small to largest, and it gives you the ability to see which buses, in this case frequency, is still oscillating. So within the last 1 second, looks like these buses are oscillating, plus or minus 0.2541, but many of the other buses in the case are going towards a new steady state. So as you can see, these values are going towards 0. So going towards 0 is good because that means you're reaching a new steady state. Otherwise, you are not. So this is one of the new features that's been recently added. So I think I have gone through pretty much what I wanted to cover today. I think I can open it up to questions. Scott, do you want to see if there are any questions?
I think most of the questions submitted on chat we've already either addressed or Jamie has picked them up. I guess we could take a couple minutes if anybody wants to just ask a question over audio, unmute yourself temporarily, ask the question, and then Saurav or Jamie or somebody can hopefully address it. I want to leave plenty of time for Tracy to be able to speak though. Okay, I think we're good for now then. We'll see if we've got some time at the end, we can just open it up for general discussion as well. But I guess for right now, thank you, Saurav, for that presentation and for running through the summary of our new and recently added features. And Tracy, are you on the line and ready to go?
I think I am, Scott. So
all right,
let me 5 minutes.
I'm going to make you I'll make you the presenter, and hopefully you'll be able to then share your content.
Okay. All right.
So again, most of you know Tracy from his many, many years of involvement in WEC at Avista, at was it USC Consultants, BPA, and now he's with PSC, North America Consultants.
That is our name and that is our job. And we provide various services to folks. And my connection with the Western PowerWorld User Group meeting would have come from my tenure as the WEC Technical Studies Subcommittee Chair, where there was a time when WEC was fostering these types of meetings and using the WEC rubric to do so. So that kind of went away, but we're still continuing it, and I'm happy that folks are attending. I work for Power Networks. We do studies, we build HVDC systems, and we do strategic advisory work for folks. Here's me in a nutshell, Naval War College graduate, University of Idaho guy, nuclear Navy guy. Employment, Scott alluded to it, but presently I work for Power Systems Consultants. I'm the technical director for PSC North America. Presently, I am the WEC System Review Subcommittee Chair. It used to be the Data Subcommittee. WEC reorganized, something WEC tends to do at times. But nominally, I'm responsible for hopefully getting base cases created and out to people in an expeditious fashion. Prior to that, I was an Avista guy, senior power system consultant there, WEC CSS chair, vice chair, secretary, the chair of the Joint Software Users Group, and the chair of the WEC RAS and Contingency Task Force. USC Consulting, Bonneville, worked in system operations. A handful of folks are still working at BPA. I think Brian talked online. Hi, Brian. Operations is really where PowerWorld, Bonneville operations where PowerWorld got its in, if you will, in the West. Modeling RAS and various features that PowerWorld is very good at really came out of BPA. And one of the tools we're going to talk about today is the ATC tool, Available Transfer Capability tool. That really had its genesis in the study of the I-5 corridor and was heavily driven by folks at BPA. Prior to that, I worked for the Joint Staff and then the Nuclear Navy. So here's something novel about me. People may or may not know. My shipmate, Rich McGuire's on this. So Rich and I were there at the North Pole the 6th of May, 1986. I sailed around on submarines, aircraft carriers, and destroyers. So it's always something to remember people by, so I throw that out there. All right, so what are we going to talk about today? Well, we're going to talk about generation interconnection, and we're going to talk about it somewhat as a generic process. I'm going to use PowerWorld Simulator to do this, but there are other tools that have similar features. You know, one that comes to mind is Terra or PTI's MUST program. They have some features that are somewhat akin to the ATC tool, PowerWorld. Additionally, I'm going to talk about other tools that aren't simulation tools that help you do generation interconnection, things like Google Earth or land grid, various GIS things. So I'm trying to take this viewpoint from a consultant's view where you really don't have a lot of support system for finding data and finding locations and the like. And I'm going to walk the dog and show people how you can work with what's commonly available and then move your way into more advanced simulations and studies. I'll make a note here. I'm not going to talk about the regulations that FERC has put in place that says you must allow non-discriminatory interconnection to your transmission system, but you must, right? So you can't say no. I think we've moved past that culturally. I think there's probably still some cultural hangover from 20 or 30 years ago where people are rather reticent in trying to adopt a customer service approach and help people interconnect. But ultimately, if you have ratepayers and you've got third parties buying transmission on you, that's good for everybody, right? They pay your tariff rate and your ratepayers see some relief. So we're going to talk about this from the viewpoint of a resource, which is not necessarily a generator. It could be a battery, and the ATC tool goes both ways, and we'll investigate that. Okay, so a couple things, methods and tools as far as a prospecting approach is. where is the resource? So there's some resources, wind and hydro would be kind of classics, or maybe natural gas, you want to be on a pipeline. Where is that stuff? So wind's pretty site specific, and it's going to define where you put things. There's other types of resources. Solar, you can pretty much put it anywhere the sun shines, and presumably you have space. And then BESS is a battery energy storage system. It can really go anywhere. So one of the tools that you want to get at is, or one of the thought constructs is, well, where can I put this stuff? Both in a geospatial viewpoint, will it fit? Does it make sense? And then pop into something like a PowerWorld simulator and figure out if it's going to make sense electrically. So I'm going to think geospatially. And I put a number of links up here to help folks know where data is at. And I'll just swap out a PowerPoint here and then go over to a web browser and display what these links would take you to. Okay, so share that content. And there we go. Okay, so this is actually a map product from the Bonneville Power Administration's GIS folks. So they've done quite an excellent job of providing this geospatial information. It's exact. You're able to download this information either as an ESRI shapefile, or you can get it out and make use of it as a KML file. A number of different ways you can manage it. You can also display it as imagery. So let's see if I can get my imagery flavor up here. And then I'll just beat up on Hathaway as a station, but I happen to know where it's at. Over here. I got to go find Lewiston. There we go. And here's the substation, the Hathaway 500 kV substation. And you can see in this particular case, Bonneville's got their actual structures, 35/2, 35/1. So if you need to perform geospatial analysis, gain an understanding of how substations put together or where lines are, or if you're routing, Bonneville certainly provides that information to the public. Additionally, if you're looking at global, or actually the United States, the Department of Homeland Security has this thing called IFELD, which the purpose of this is Homeland Security imagery analysts basically scour the U.S. with all the map products that come from the National Geospatial Agency and then various imagery. And this is provided for first responders, urban planners, and the like. And it's quite a useful tool. The data could be downloaded here at this website. You can either get a spreadsheet, KML, shapefile, various flavors. I plotted the whole thing in ArcGIS. And so here's basically every transmission line of note in the United States. You can see Puerto Rico down there in the lower right-hand corner. But each one of these lines, you can actually interrogate the data and then find out what the line is, what the source is of that data. Some will say it's imagery, some will say it's a BPA map product, or CEC or a California ISO map product. And then just to round it off, I'll just throw the California substations up here. They're all plotted exactly. CEC actually requires that information to be made public. The transmission lines are also there as a layer. So these are all tools that are helpful for someone to just start thinking geospatially, understand the nature of the stations that you might interconnect things at, and it's a good background to kind of start from. So let me pop back into PowerPoint. Okay, so back to PowerPoint here. So thinking geospatially, we walk through what BPA has for data, what CEC has for data, and of course what DHS has for data. There's also other information that is somewhat helpful. And all this is trying to lead up to understanding what's happening on the ground and being able to perform some qualitative analysis before you might jump into more sophisticated modeling, which could be viewed as quantitative analysis. So LandGrid is a handy tool, and what LandGrid does for you, I was just walking through these slides, but actually that's probably worth it. Right, here's the BPA data. Here's what comes out of this shape file, Lost River, Spark Canyon, that's the little line down there. This is me reading a shape file into PowerWorld Simulator. You'll note that it looks precisely like it does in the BPA GIS application. And here's zooming in, taking a look at the Hathaway substation, and then just picking off the Dvorak line, Dvorak to Hathaway. The CEC stuff, just zoom in of what that is. And then, of course, the DHS data, it's complete. It covers the entire United States. And if you were to select any line, it would tell you where it came from. So here's something that a tool that's out there. It's helpful because what these folks do is they look at county tax records. Here's a close-up image of the Hathaway substation. You can see I selected that polygon, and it comes back and says, hey, here's the parcel ID, Bonneville Power Administration, et cetera, et cetera. So for those folks of you that might have to start from scratch or support developers, oftentimes you'll find yourself doing work that has nothing to do with PowerWorld Simulator, but it's that qualitative analysis that then sets the stage for you to go to that next level. Okay, so now we're going to talk about the methods and tools of exploiting base cases and trying to figure out what kind of information is in that base case and how can you use it to be able to select a good location for a resource. Now again, if it's a wind resource, you pretty much got to go where the wind's blowing. But if it's something like a battery or solar, they're a little bit more flexible as where they could be interconnected. But I think most of us would agree that you would choose a point of interconnection based almost solely on the least amount of expense and the least amount of pain to get that project in there. And the ATC tool and the rest of these tools we'll talk about, they'll help you size that project to be big enough to get some value out of it, maybe get some economy of scale associated with it, but not so big that you're going to have to build new transmission and the like. So one thing you need to do is choose your case or several, right? I think the definition of cases these days is a little bit more flexible than we used to think. Talking about that a little bit. One of the things you want to do would be helpful to use that aggregation idea of a substation. And then once you have a substation created, you can filter, I call it by interconnectedness, but voltage, number of tie lines, et cetera. New feature that Caroline added was the simulator now counts basically the number of ways out of a substation. It's pretty handy. Then you would insert a resource or a generator, throw together some injection groups, perhaps some interfaces, go through the contingency process, and then screen with the ATC tool. And when you run the ATC tool, what you'll find in a real case is that there's going to be some contingencies and some limits that are just going to show up, and you're going to know that they really don't have anything to do with the resource. And those are the kind of things that you can kind of tune or call out or screen out. And then ultimately, the ATC tool is going to give you reasonably accurate results, but it's not going to be as definitive as an interactive power flow. So use the ATC tool to get smart, hit the interactive power flow, make certain you believe the answers, and then perform other analysis. Like throwing out there a PV analysis is a good idea if you're going to just stay with the power flow world. And obviously, if you're going through a generation interconnection process, you're going to do short circuit analysis and transient stability analysis, all which can be done with PowerWorld Simulator. Unfortunately, there's just no way we can go through those features interactively, quickly, in an hour. I mean, I would tell you that this is a 3-day class. There is a 3-day class for this stuff. One of the things is to shout out to Scott and Scott's famous radio voice. If you have not listened to, hi, I'm Scott Dowman from PowerWorld Corporation, you should go to that training environment and, watch the videos and go through the slides. And you will then pick up those nuances of where to go, what button to click, and really how to drive PowerWorld. The ATC tool itself, I've thrown a link in there that talks about it. It is a very complicated, very powerful tool that you might find very confusing at the first time you use it, but an hour into it, you're going to gain a lot of insight into what you're studying, which is the whole point of it. Okay, one of the things about WEC base case selection and preparation is, what is the right case? As I'm throwing out, as I'm talking about it, I'm going to also throw out that folks who that hopefully everyone here is a WEC member. There might be some people that aren't, but join WEC. There's no charge. Sign an NDA. You get access to base cases, and then join SRS and help us out. One of the things that we're seeing in SRS is that presently we're starting to see a trend where maybe what people are seeing in reality and what we're modeling. I've received reports that people are thinking there's a difference between our WEC models and what they're seeing operationally in reality. And obviously we are interested in that, and we're going to tighten down the screws and try to figure out what's going on there. I would throw out there often, traditionally, heavy summer is a limiting case, right? It's hotter out. The definition of heavy summer, though, used to be like serving load. I'm not certain. I think our definitions are going to change. I'm not going to beat on this thing a lot, but California's solar output's quite tremendous, 12 gigawatts, maybe 14. Your intuition is probably not as relevant as you think. And the ATC tool will help you with your intuition. It's quick. It will pound through various transfers and contingencies. And you might want to pick up more cases when you start looking at integration studies than you had in the past. So you should definitely expect to study a number of cases. 4, 5, that's probably enough. 2 seems to work often if you've got a lot of experience in the area and you're working out a utility. You kind of know what's going to be limiting. One of the things I would suggest to you, though, is that you should consider fully dispatching anything that's a designated network resource or firm contract resource, because they've got firm transmission capacity. If you don't have them at their full output, then this new project would be presumably using some of that. So this gets into the FERC definitions of a network versus an energy resource. And this all sets the stage for actually doing the study. Okay, so there's a case where I'm just throwing like a generator in left a hat way, right? And so I'm using actually the bus view as a tool to stick a generator in. It's not really a well-documented or maybe even supported feature, but I just go get the network generator, drop it on hatway, and then ask me about what I want that thing to look like, and then boom, I've got a generator in play. And then that generator, I go ahead and I go to the generation record, right-click, go down to generator records, and I can make an injection group. And I desire to make an injection group because if I have injection groups, it gives me all of the tool sets in the ATC tool. I can use the iterated linear environment with injection groups. There's some limits on what you can do, and injection groups free you from those limits. Then you got to have a place to send that resource to. So I'm a real advocate of building an all-WEC generation group. In this case, all-WEC to me is I'm just going to take something with a Pmax over 10 megawatts, a Pgen over 10, and a Pmin over 0. I don't want pumps and things to be part of this. And then once you build that thing, you can exclude or include what you want. I mean, typically what you get is an injection group that's, I don't know, 140 gigawatts, and you're going to put 500 megawatts into it. So ultimately what happens is nobody really moves very much except for the resource that you're trying to interconnect. If you're going to study a network resource, then you would need to consider syncing that to the designated network resources. This, of course, becomes a problem if you're working at a utility with maybe 2,000 megawatts of network resources and someone wants to interconnect 1,000 megawatts to your transmission system. Then you're probably going to want to go play the all-WEC game. But, you know, network resources, at least in the beginning, they should be decremented for somebody who wants to show up and take advantage of that transmission pipe. Energy resources, that pretty much goes to the all-WEC injection group. And then you should consider excluding your designated network resources from that all-WEC injection group. If you don't, it's really not going to be a big deal because your generation likely will only change by a handful of megawatts at any single generator. Okay, so then one way to limit the number of possible substations that you would want to examine would be to create and filter substations. First off, you need to make substations. I think everybody in the West has them. We've been doing geomagnetic disturbance studies that require substations to be created, and I think most PowerWorld users have those. If they don't, you know, WEC's got them. Various consultants have them. They're available, and PowerWorld has tools that help you make them. And all of those geospatial tools that I previously referenced will help you quickly create substations. But here's an example of a filter that would be useful, perhaps, to look at a place to put resources. So typically, higher voltages are better, and numerous tie lines from a substation are better. So one of the new features here, Caroline simply recently added this, and that's like the number of tie lines is counted by simulator itself. It used to be you had to go through some machinations to count the tie lines, but now it's actually counted. So that's displayed by going to the right click and display column options, and you can display number of tie lines. And then you can see the filter that I've got going on here. I'm saying, look, I want to display only substations with the nominal minimum kV of 200, above 200, and then maybe 4 tie lines. And then you can, subsequent to applying this filter by owner, et cetera, and then you'll see a list of substations that can be pretty favorable for selection as a resource location. And then you would need to put a generator in there and make that an injection group. Or you can just do a quick screen by going from a bus within that substation to the greater WEC injection group. I'll throw out that this is a great example, Seattle City Light. So maybe your electrical screening comes back and says the Broad Street substation is a great place to go put a bunch of stuff. But if you show up and take a look at it with imagery, and this is where it's sort of iterative, you want to bounce from the imagery into the simulation environment and back again. You'll notice we haven't actually run a simulation to get here. But here's Broad Street and there's the Space Needle. Probably not a place that's suitable for a lot of development, right? And that's a reasonable thing to do, and I think most people do it. Certainly developers need this kind of assistance. Throwing some trivia out there, right? This is KML kind of data, and KML stands for Keyhole Markup Language. It's actually government software. It was paid for by the CIA a long time ago, but that's why Google Earth is free, because Google didn't write it. Okay, this is a quick example, and then we'll get into more PowerWorld-centric stuff of what the world's largest battery presently looks like. And this is in South Australia, Hornsdale Power Reserve. So it's a 100-megawatt Tesla facility, 129 megawatt hours in it, and it basically covers about 2.5 acres. And it's pretty small, and it's something that it's actually smaller than a substation. So I think the future for people that own transmission and are transmission planners and the like is they're going to start seeing things like this plugging into their system, whether they develop it themselves or others do it. So small, and the methods that we previously discussed, the imagery and the like, would help you screen out your stations as far as this just isn't going to fit. And then electrical performance is the next thing you want to test. So the ATC tool is helpful to facilitate studying the transfers from a resource to some other place. So I just picked Catway because it's a government station. Flonable's posted all that data, and I can grab a wet case and show little images like this and not break any rules. But when you enter into the ATC tool, first off, you got to recognize you got to go buy it. It's not terribly expensive, but it's an add-on. And when you get there and you go to advanced options, you're going to see there's 3 particular methods that you can use. There's a single linear step, the iterated linear step, and then iterated linear, then full contingency solutions. So there's a lot of material posted online on the PowerWorld help page that explains this in many pages of detail. Fundamentally, what you're looking at here is a single linear steps can take advantage of linear power transfer distribution factors, and everything's going to be trying to linearize everything. So very fast. The iterated linear step is going to take you out to the point of transfer and then run the contingencies in a linear fashion. And then iterated linear is going to basically go run the contingencies, right? So in order, it becomes a longer period of time to perform the analysis, but it also becomes more accurate. Typically, I find myself, and I imagine others do the same, I just start with a single linear step and just run, look at the contingency results and the limiting elements that it returns and decide if they need to be ignored or not. And then I just jump from single linear step and I basically go to iterated linear full contingency solution when I get the sweet set of contingencies. And when you set this thing up, you get a choice of how many transfer limiters you're going to save, and then max limiters per contingency. So a contingency could cause maybe 10 things to overload. Maybe you only want to set it to return 3, right? After that, it becomes somewhat repetitive. And then how many times will an overloaded element be reported? And you might put in 3 or 20. And then ultimately, there's some limitation to how big the transfer is going to be. It could be 1,000. I put 10,000 in this particular case. And then the sensitivity tools are then made available to you that you can ignore lines or elements that have small power transfer distribution factors or outage transfer distribution factors associated with them. So what you get out of that is something like this. This returns the results. And what I did was I auto-inserted 27,000-ish contingencies. And I basically just said, give me everything in whack. And then I put these controls on it to where I only wanted 20 limiters, 3 limiters per contingency and 3 limiters per element. And then I said, okay, go and tell me maybe how much you can shove into the 500 kV bus at Hatway. And then various contingencies are run against it. And this was just the single linear approach, and it returns these values. And then based on maps and one's knowledge of the system, you can look at it and say, all right, that Hatway lower granite, limiting contingency comes back with a tablet to wall-to-wall at 230 problem. That's a keeper. And then you've got this Malin Round Mountain problem. That's not really a Hatway kind of thing, right? Even though the PTDF and the OTDF are bringing big numbers back, it's because there's a lot of generation in California, and your WEX sync is gonna show that. So those could be something that you would consider just skipping. Obviously, you'd want to take a look at those, and what you'll find likely is that there's maybe a series capacitor involved in there. It's maybe nearly at its full limit anyway, and those are the type of learning experiences you just go ahead and say, I'm going to skip that contingency, or I'm not going to monitor that element. And that's why the skip contingency and monitor element yeses and nos are in there. And this is where you sort of teach the ATC tool what actually matters and what's important, but you best be comfortable with it. So this is one of the things where you want to get interactive with that. And then as you march down through this stuff, you'll end up with a modified contingency list and a modified limit monitor list that is appropriate for the ATC analysis that you're performing. And that's the advantage of going to the single linear step, is just get it done quickly and then turn off those things that are kind of spurious reporting and then move on. Or you can just report them all, make it a very large list, and then manually remove them. And then the results of this stuff, you come back with, in this case, I ran it just to try to figure out what the base case limits look like. So rather gigantic, right? 500 kV system is pretty powerful stuff. So loading things to their limit, all lines in service, is actually a substantial injection of power. While you're doing the ATC analysis, I'm going to strongly suggest that you go examine the sensitivity tool. Either do it before you're doing the ATC work, or make the ATC tool make questions, go to it and say, well, how does the power get out of there given my two injection groups? So I've got this case where I've got Hatway dumping it off to the all-WEX gen set. I hit the shift up arrow when I sort, and that gets an absolute value sort. So you look at it and say, okay, not surprisingly, it's coming out of Hatway, it's going to lower granite. It's coming out of Hatway, it's going to Dvorak. The from two start giving you signs, right? It's always the square root of 3, square root of 2, or the square root of -1, or -1. You know, there's always something going on in this field of study we're in. And in this case, you have to understand that in the case of like Dvorak Hatway, that's the definition of line. So if you're injecting at Hatway, it's going to be reversed, right? It's always important to reiterate that. But this allows me to understand how that energy or power is going to flow out of Hatway, given the definition of my receiving injection group. And then that helps you think harder and smarter about what's going on. And then you go back, leave the single linear step, and then turn up the heat and go to iterated linear full contingency. And so I copied this section out of the help manual. And, you know, fundamentally it says, hey, we're going to take this a step further. We're actually going to go ahead and do the full contingencies and solve it with the full power flow solution. It is slow, it is accurate, and I think it's important that you teach it, the ATC tool, what to monitor and what contingencies to run by maybe repetitively running the single linear step. And then once you're happy with your contingency set, you run the iterated linear and full contingency solution, and you're going to get solid answers that you would subsequently be well advised to check with a regular power flow, interactive power flow, and contingency analysis, so that you would put the generation in play figure out how to decrement generation elsewhere, fully integrate it, and then perform your normal suite of studies. The advantage here, though, is that you're going to do it with the most notable list of contingencies and limiting elements possible. So you don't have to go screen a bunch of stuff with full AC power flows manually. You can use the ATC tool to help you get there. And all of this takes maybe 2 hours tops for someone who's done this enough. It's like, oh, yeah, I got it. And then I would tell you that you should finish with a variety of other tools. And I can get interactive with this stuff, but I think we're right at 10 o'clock. So, but here's a case where subsequent to the ATC analysis, I would run the PV tool, and I would basically run the contingencies, bring back a limited set of them, maybe 10 or 20, and lay down the plot. So there's a lot of reactive control in the area of Hatway, and so you see all this jagginess. But what I've got here is I've run 2 contingencies and the base case. So we start out the base case, that's the blue line, and it just motors on out to some ridiculous number like 4,500. And then this is me interconnecting a generator at the 230 bus at Hatway. You can see that the transformer is the limiting element there. And you start cranking it up, and then some reactive device switches in. There's reactors out there. There's capacitors in the area. You end up with this kind of jagginess, and then suddenly you reach the cliff and you go over. So if you're doing work as a utility for developers and people are asking you things like, I want to put 50 megawatts in here, FERC has some tight rules on it, and they can't really, you know, if they're going to ask for 100 and they ask for 50 to begin with, they're going to have to reapply and get back in the queue, maybe spend some more money. One of the ways you can increase your customer satisfaction, and probably more importantly, not have to do more studies, is to do a PV run and let it go out to the point of failure. And then any sophisticated developer would look at it and say, wait a minute, I asked for 50, maybe I need to ask for 150. The ATC tool can bring back those results as well, but the PV tool gives it to you in a nice graphical fashion. It's a full AC power flow, and you're plotting voltage at the same time that you're conducting contingency analysis. So it's relatively definitive when it comes to power flow analysis, and it nicely sets the stage for subsequent system impact work and the like, you know, the fault duty and the transient stability studies. So I would suggest strongly that there's a variety of takeaways from this presentation. One, use the ATC tool. It saves you lots of time. Don't send the generation output from a new resource or generation interconnection project to the slack bus. That's just poor form. It ain't going there, right? It either needs to go to something you control, or you dump it off to the WEC system at large. And the WEC system at large is so big that no one generator is going to move more than like a megawatt. So it's going to just suck it up, and it will tell you what the real problems are. And that the PV tool is something you probably most definitely want to use, because it will tell a story that a sophisticated developer should be able to process the story that's being told to them, and perhaps they will either they'll change their request. If they can't, you know, if they ask for 50 and 49 works, well, then they'll ask for 49. But if they ask for 50 and 200 works, they're just going to pay you, the transmitting utility, more money. So they hop out of the queue, re-queue, ask for 200, and those are the types of things that they can take away from a curve like what we've got here. And that is it. I think, you know, we've talked about, the folks at PowerWorld, myself, about how to try to reconnect with the people that use PowerWorld Simulator in a COVID-19 environment, and this is it. I think what we're looking at is maybe performing these types of presentations monthly, an hour or two at WAC, and then try to piece them together so that we can introduce concepts and tools either interactively with the software itself or maybe driven by a slide presentation that can be used as a reference for folks in the future. So one of the things that we're interested in is feedback. It's pretty evident that interaction with the software equals, it ain't a 50-minute course. It's going to be quite a bit longer. And I think we're happy enough to go there. We just want to get feedback from folks and understand what they find useful. This generation interconnection subject, I just basically gave you a small sample of some of the tools that can be used to start that type of work. It really is a 3-day course if you want to dive in and actually work through the Texas synthetic grids or a wet case and the like. I mean, it does take that long to actually get everybody to go through it. So to some extent, maybe we're setting the stage, and if people are interested in that, we can just break it up into pieces and get there. So that's it. Any questions? Feel free to ask.
Thanks, Tracy. This is Scott again at PowerWorld Corporation. I'll just reiterate in case people didn't see them. There was a couple comments that came up in chat, and Richard McGuire just pointed out that ATC is handy given the current pro forma LGIP, I believe that's Large Generator Interconnection Procedures from FERC, Post Order 845, which asks the study not only show the impact of the requested generation, but also how much generation can get in without the need of network upgrades. So obviously with the ATC, you're not really capping a max on, well, you can cap the max within the ATC, but generally you can also open it up so that it can just ramp out till it hits limits. So even if your limit is beyond what a proposed project is, you can still get some useful information out of the ATC. And then also, of course, it gives you multiple limiters so you can identify if you're able to remediate some of the first few limiters, then what other constraints are you likely to bump up against. And then we also posted some links to some information on using the multiple element TLR, which we found has been a really useful tool if you're trying to screen locations. So in the early on, as Tracy was mentioning, you can look at GIS tools and all these other things to identify locations. On the electrical side within Simulator, you can run multi-element TLR, and that's really handy. We've done that with some studies where we just put in a bunch of contingencies. You first run the contingency analysis, and then you'll have a bunch of overloads that come out of that. And then you can run the multi-element TLR on contingency overloaded elements. And then what you'll get out of that is just kind of a measure of which locations tend to relieve the overloading that came from that set of contingencies. By itself, it will not tell you what the ATC is. You could still bump into some limits very quickly beyond the initial injection, but it will tell you which locations tend to make things, existing problems on the system better. And it's a good screener. And then from there, you can dive into the more detailed tools like the ATC and the PVQV and things like that. And I guess I'd also mention that we do have some training topics on our website that deal with interconnection. It's under the security analysis section of the website. I'll post a link up to it also in the chat. All right, great. With that, I think we'll just conclude the session this time.